So let's talk about tooling. A little bit about why I'm doing what I'm doing, what I expect to achieve by doing what I'm doing, and both in cutting the base and cutting the squish, or the squish band. Um, the original reason that I started to want to cut the base of a cylinder was to just correct the squish clearance. Um, so, a lot of saws, they were, 30 or 40 thousandths of squish clearance, and we wanted something more like 20. And we've even tried tighter than 20. You can, but it creates other issues. So 20 is probably about an ideal number. You can use it all the way across, from a 40cc saw to a 100cc saw. So it's pretty much a number that I just stick with and go for. That works for me. Everybody's got their own preference. So when I first started with making mandrels, this was one of the first. Actually, I took cylinders to another machinist and had him cut them, and he kind of got me the idea of what to do. He didn't do a very good job, and I wanted a better job, and eventually bought a lathe. Not a good lathe, but a lathe. So making a mandrel to turn the base was quite simple. Really all you need is something that looks like this, no cutter in it, that kind of stuff. It's just a simple slide the cylinder on there and go ahead and cut it. It's friction fit, a friction drive on it. It puts pressure on a tailstock, friction drive. I don't like to over tighten stuff. I'd rather, if it slips a little, it slips. It's not the end of the world. I polish these mandrels, so if it does slip, it doesn't do any damage whatsoever to the plating in the cylinder. And I'm pretty fussy about that. I have wrecked cylinders in the past and had to replace them for a customer, and I don't enjoy having to do that. So as we learn, we correct ourselves. So this is one of the very first ones that I built on my own lathe. I had lots of problems with that old lathe, but I tried a lot of different cutters in the top of it. I spent some time with some other machinist friends. We tried some carbide inserts, but you couldn't adjust them. We had issues with all of that. We tried to leave it stick out far enough to grind it, to get the depth right. That really wasn't the answer to the whole thing. Then on this one, I just took and I cut across in it, and I sharpened every one of those four, and then tried to cut with that. Well, it sort of worked, but it's just common steel. I don't know what this piece was, and it dulled right away. And I really couldn't get right out to the edge like you'd think you could. It just didn't work as I thought it would. So eventually I put a single cutter in here, and this cutter is nothing more than this is a 1/4 inch by 1/4 inch 5% cobalt bit, high-speed lathe bit, and this one's been cut in half. I don't have a new one. This is just a piece I have left. And I started putting these in there. And then of course I got to grind all my clearances to make it cut. And it took some time to decide where in here this cutter should be. Some of these I've got offset more for the center, and you know, some are centered in the center. The whole thing is centered, and some cut better than others. Part of it is the amount that the width of the squish band makes a difference on how hard it cuts. The material the cylinder is made out of. Does the plating go up over the top? Are you cutting through the plating in order to adjust the squish? So, but the main reason that I started to do this, like I said, was to just correct the squish clearance. And as time went on, I realized that there may very well be other benefits to this. And I started playing with port heights, where I would actually run a shorter port duration than stock. There was some benefits to this, and we had realized that when we were doing gasket deletes and stuff. And you know, you could get, oh, I don't know, maybe depends on where you're at and elevation and everything, but we would go from like 160 to 170 pounds maybe, but like a 10 pounds gain in compression by deleting the base gasket. Compression gives you a little extra torque. Correcting the squish band, it gives you a little more power. The fuel that's trapped under the squish band doesn't really add to the power of the motor. That fuel is basically lost. It kind of burns, but it burns really late in the cycle, so it doesn't add much of anything to making power. So the tighter you can run your squish, the less fuel losses you have in your squish band, the more power the motor should make. The other thing is that the squish bands were erratically shaped. A lot of them were nothing more than castings and not really clean and smooth and perfect. This is a 660 cylinder. It's the one I just cut, and you can see in there I cut just a whisper in that band, and the band is a lot wider than what even what the camera is going to show. After I cut this, I'll show it again in another segment here, but I stuck it in there, and this is cut very irregular. The newer cylinders, the newer saws, like 661s, 461s, the manufacturer started to cut the squish band flat and square. And I have been doing this now for probably 15 years. Been cutting that squish band flat. I tried some tapers and some angles and some other stuff, and I determined that flat was what was performing the best. And you do have to pay attention to how wide the squish band is. Rule of thumb is 50% of the surface area would be squish band, and the remaining 50% would be your combustion chamber. And to get a combustion chamber that's properly shaped, that's about right. However, physical width, the wider the band, the more squish velocity. That's hampering compression. It makes the engine fight itself. So sometimes you may want to narrow up your squish band, and I would just add a little angle in there on the inside, maybe 2 or 3 degrees, but not the entire squish band. I'd only do part of it. I would leave, so I don't know, maybe as much as 3/8 of an inch, a quarter of an inch anyway, of flat squish band, and then I would taper it up, maybe 2 degrees or so, and I think that would alleviate high squish velocities. So I started to lower my exhaust port. That was the main port I wanted to lower, but there was some saws with transfer ports that were higher than I thought they should be, and then you could lengthen your intake port duration without making the intake port larger, so you didn't mess with the flow characteristics of the port. So those are all interesting things that experimented with and learned and done, and been through all of that. So when I first started, you know, these were some of my early mandrels, and I just cut them to fit the cylinder. I didn't cut it to do anything else, and added the cutter into the top of it. You can see on some of my early videos that I cut and I don't have this tool, this piece. So I would cut a little bit, and then I would use a sanding block like this, and I would flatten it out again, and then I would put it back on a saw, and I would measure, see where I was at, and go back and forth and back and forth. And eventually I would get there, but I had to be pretty slow and towards the tail end of it to not go too far. Otherwise I have to cut some more off the base, and I might not want to do that. So a good friend of mine came up with this, and I had tried a few other different things. Some of my mandrels have holes in them, drilled in them. I was playing with all kinds of different ideas for a depth stopper, whatever you want to call it, whatever you want to call this. And I didn't really come up with anything. I had an idea of threading the shaft, you know, having this threaded on here, having something I could screw on there, screwed all the way down. But I have to screw that up from the bottom. This can't have threads on it, of course. And a friend of mine came up with this idea, and I said, yeah, I had thought of something, you know, similar. And then he decided he was gonna make me one, and so I said, well, I've got some material here to make mandrels out of, and so I planned it at that time to make new mandrels, and this is what I'm using. I don't know what this is. It's steel, but it's a drop or a remnant or whatever you want to call it. Someone who knows more about steel can tell me. It's painted black on the end. I was told that represents what the metal actually is. I don't know what it is. And it's not 2 15/16. I got a chuckle out of that too. It's a little closer to 2 7/16. But anyways, the size of this is just a little more, maybe 60 thousandths larger than, say, an 084, 088, 3120 cylinder. So we decided to make this basically 60 millimeter on the inside. That's what a 88, 3120, 084 is. So it's slightly over. We went with a standard size. So I don't know, it's like 3 thousandths or something bigger than 088, 084 cylinder I just recently done, and so it fits relatively close to diameter. So an 88 cylinder, you're not taking a whole hell of a lot off, and it's a little loose up here. It's a little bit tighter down here. So what is this? Well, it's made of tool steel, and this was a prototype. This was a trial and error, and we didn't know what we were doing. Neither one of us. We kind of had an idea of how we wanted it to work, but we weren't just exactly sure how everything should be done. So he chose to do 20 threads per inch. So one revolution of this is 50 thousandths, and put increments on it here. He had some marks here on the side, but eventually I just used this cut spot here for my increments, and each line there is 2 thousandths. So I can go down 2 thousandths or 4 thousandths. I generally cut 4 thousandths at a time. It makes a easier cut that way, or flatter, stays flatter, and I just keep working it down. 4 thousandths, cut it till it cleans up. 4 thousandths, cut it till it cleans up, and I can count how much I'm taking off. So on this particular cylinder, I didn't check my squish before I cut this. I checked my durations. I determined that I'm just going to go ahead and cut 40 thousandths off the base, throw the base gasket away. We seal it with Durco. It's what Steel uses on all of their saws. I've never had it fail. It's easy to remove. So if you're taking a saw apart, putting it back together, a lot of times that's the easiest product that I can tell you to use. This is made from tool steel. It was one piece. It was a little over 2 inches long. He split it in half. He ended up with two pieces approximately an inch long. Put the 20 thread per inch into it. So when we first started with it, this top piece was not cut. Right here there was a hole drilled, and we put a piece of plastic in there and put a set screw behind it to set it. And I had issues with that. It left this sort of somewhat loose, and every time I went around this cutout, it would snag and catch and give me all kinds of crap. So I took the piece of plastic out, I put a piece of lead in it, and that didn't work any better. So in order to use this, I had plans on making a new mandrel, but I also had plans on buying a different lathe. And I didn't want to make new mandrels on my old lathe, so I waited and I made these bushings. So I can put the bushing on, and I can put this over the top, and this works fair. It's not the answer, okay? Bushings come back off. I got to fight with all of this stuff. The old lathe wasn't perfect, so by making the bushings, it doesn't mean that this is square anymore. Nothing's perfect. So got a new lathe, spent some time on it, got it fixed up, had some problems, took care of all of that. We've been making some mandrels. So this is a new mandrel. This is the last one I just made. Kind of trying to decide exactly how I want them. I thought when I made the first one that, you know, 1.5 inches for the chuck to chuck on, and the shoulder so it could push up against the chuck to help hold it in place, and it couldn't slide in and all that kind of stuff. I thought that was all a good idea, but 1.5 inches wasn't very smart when I have about 2 1/8 of jaw on the chuck. So why not make this 2 1/4, right? So that's what I did on this one. This held a lot better than it did on this one because it's only 1.5 inches. So I'll be either trying to fix these, or hell, I'll start over if I have to. So that's what this is, and I eventually cut this outer ring and split it. I welded these bosses on here, drilled a hole, tapped it, put a screw on there so it clamps down solid. By clamping it on there, it stays put. It doesn't move. And like I said, increments of 2/1000ths on there, and I'll be taking almost a full turn. This cylinder is dropped about 60/1000ths. I don't, like I said, I didn't check squish clearance before I started this process, which brings up another thing that I want to go over is why this method. Well, you know, as you've seen in the video, when I touch off onto the cylinder, you're taking something off. You know, is it 2/1000ths? Is it 5/1000ths? You're always taking something off. So you measure your squish prior to, and you have problems there. This is 31/1000ths, I believe, 32/1000ths, 60/40 rosin core solder. It's a soft, hollow solder, so it squeezes pretty well, but it's only 31/1000ths. It gives a pretty accurate 20/1000ths measurement. Somewhere between 15 and I don't know, 28, you'll get a fairly accurate measurement out of this solder. Tighter than 15, it's always going to say 15. It won't squeeze much past 12. So now let's say you got 40 or 45/1000ths when you're checking the saw. So you fold this over, and maybe you fold it over again, you know, and okay, we got it up to that. Well, then we start twisting this thing up, you know. Okay, so now we got something to stick in there that's quite a bit bigger, right? And we squeeze that in there, and then we take our mic and we mic that. Well, who's to say that those crimps, once it's compressed, actually doesn't spring back a little bit, and it becomes a little bit loose, and you get a false reading. How much? I don't know, you know. So if you're gonna mount this up and you're gonna cut you say you cut the squish the way I cut squish with a mandrel, which is how most guys do it, and then you're gonna mount this backwards on a faceplate, and you're gonna go in and you're gonna go in there with a boring bar, and you're gonna cut your squish, and you've touched off out here when you cut your base, and you say, oh well, I cut the base 40/1000ths, but I cut it more than 40/1000ths because I had 40/1000ths on the dial indicator, but what did I take off when I touched off? 2, 5, something. When you go in here and you touch off again with your boring bar, you're doing the same thing. You're guessing. You can do all the math, you know. You say you had 40/1000ths of squish clearance, you want 20, you took 40 off the base, you take 20 out of the squish bed, and you keep your gasket, and theoretically it comes out, but it never works out that way. It'll be 24, it'll be 18. If you want, with me, I want it 20. It's going to be 20. So that's just me. That's what I want. That's what I'm going to put into it. I'm that fussy on what I do. So 20/1000ths, 20/1000ths. If you buy saw from me, you're going to be within 1 or 2/1000ths of that 20/1000ths every single time. I repeat it, repeat it, repeat it. So compression ratios are going to change a little bit because it's a casting. I go more off from port durations, that type of stuff, than I do over compression. Compression is not my key reason to do this. Port where I want those ports to be at, that's key. If I can take a lot off from a base, you know, this is a thick base, some saws are thinner based, you know, you're limited to what you want to take off of that, they'll break. Some saws are more prone to it. This one here, man, you can take 100,000s off of this and you're not going to break it, but you're not going to have a saw that's going to last either, because it's going to have too much compression. So a number of things you can figure out for yourself. You know, this size saw, 660, you know, maybe 200 pounds. You know, that's pushing the limits for my liking on a work saw. Race saws are different. We're not so worried about a race saw blowing up or going bad fast. We're there to make 3 cuts, hopefully, and that's all we need to do, and we're done for the day. And you know, man, it takes a guy a couple years to truly burn a gallon of gas, if he doesn't race every day, you know. And I don't test or practice with a true race saw. I have another saw that's relatively close, but it's not the same, you know. So I'm cutting a base, I'm cutting the squish to alter my ports more than I am my compression. So that's the development. You know, it's been oh shoot, I would say close to 15 years or more since I started doing this, and I don't know. It's just what works for me. You know, this isn't all that necessary to port the saw for work saw. I get a little bit more than most guys get. I think I give everybody their money's worth. I don't charge an outrageously high price for port work, I don't think, for what I do. And you know, you got to consider all of this, time and development and testing, and geez, my cants that we build, and you know, it's a lot of time, a lot of effort to develop a saw. One saw, the 462s, I think I've been working on those now for 3 months. The first couple saws I get, you know, relatively close. After that, there's small gains. The 661s, I've been working on them since they've come out. I don't know how many of those saws I've done, a lot, and we are still tinkering with little small changes, looking for little small gains. You know, is it worth it? I don't know, but it's fun, and that's what this is about. Have some fun, you know. Don't bother all the other builders. Don't bother me. Don't bother everybody about port numbers. You know, how you read a degree wheel, how I read a degree wheel ain't going to be the same. We've set this stuff up before and had different people read it and try to understand it, and everyone comes up with different numbers. Same saw, you know. I mean, just time that saw out, and so, you know, find your own numbers. That's part of the fun, learning and understanding, and have some fun with it. And you know, don't go stupid crazy on stuff until you understand what's happening, what you're doing. You know, I wouldn't recommend taking 40 thousandths off every cylinder you cut. I've got cylinders, certain model saws. I only cut 5 or 10 thousandths off and ditch the gasket. And I ditch the gasket on almost every saw. It's easier for me to time if I'm going to replace a gasket. You know, gaskets aren't flat.